Hello, this is second video on greedy algorithms. Let's discuss other problem. Given an array of intervals where intervals of I start and end, return the minimum number of intervals you need to remove to make the rest of intervals non-overlapping. Note that intervals which have only touch at a point are non-overlapping. For example, 1, 2 and 2, 3 are non-overlapping. The size of the intervals is up to 1 if I and intervals length is 2 and start and end can go up to 5 if I and they can be negative as well. So the question is asking us to remove the minimum number of intervals so that the rest of intervals are non-overlapping. For example, the array is 1, 2, 2, 3, 3, 4 and 1, 3. If we just remove 1, 3, these all will be non-overlapping because it is given that two intervals with only a single overlap point are considered non-overlapping because 1, 2 and 2, 3 are non-overlapping and 2, 3 and 3, 4 are non-overlapping as well. So if we just remove 1, 3, these 3 are non-overlapping and the answer is 1. So we have, let's say we have removed all our all overlapping intervals and finally we are left with non-overlapping intervals. So let's say we have some set of intervals before. Which one is better to consider for the next ones? Let's assume that this is the first interval we have and this is second interval and this is the third one and this is the fourth one. For third one, which is better to live with, we have, because these two are overlapping and we have to remove at least one from this to get non-overlapping intervals. So which one is better to live? So let's see according to third one. So if we try to remove second one, the first can be paired with 3 because these two are non-overlapping. So with respect to 3, removing 2 is better and keeping 1 is better. And with respect to 4, both are overlapping because this endpoint is here and the start point is this, and even this endpoint is this and the start point is this. So with respect to 4, both should be removed. But at least with respect to one of these, 2 should be removed and one should be there and it should not be removed. So it is easy to understand that if we have an interval with smaller endpoint is surely better than the interval with having larger endpoint, because even in future there may be an interval with start just greater than end, so that this can be paired with this one. So it is like the more probability to the smaller one so that it can be paired with some other intervals in future. If there are some intervals that are pairing with bigger one, they will surely pair with the smaller one as well. So for example, these two are intervals and this is the new interval. It can pair with this as well, but it can be paired with this also. So all that satisfying for this will satisfy for this as well. But interval satisfying for smaller one will not satisfy bigger one. Because let's say this is the interval and this can be paired with this, but this cannot. So if we have some intervals and if they are overlapping, then we have to remove the interval with larger endpoint because it reduces the scope for future pairing. So now we will remove one or two, so surely two as we discussed. So from this we can come to an understanding that it is better to have intervals based on end time. So we can have more non-overlapping intervals and hence reducing answer. So if we have some intervals based on according to endpoint, we can understand that the first one will have lower endpoint. So obviously we will keep the first one in the pair in the scope and we will remove the second one from our answer. So we understood here that according to endpoint it is better to sort, because if we sort according to endpoint, the first intervals will have least endpoints. Maybe the start points are very different, but endpoints will be surely in the sorted order. So then based on the condition, if they are overlapping, then we can remove the interval with higher endpoint and we can keep the one with smaller endpoint. So sort the intervals based on end times. Let's say this is the new sorted vector of pair. So as we can see, the endpoints are increasing and maybe the start points can be decreased because we are sorting just with respect to endpoints. So now let's start simulation. For example, this is the first interval, so let's keep that in the non-overlapping set. So let's come to the second one. So coming to this, obviously the endpoint of before is greater than the starting point of this. So these two are overlapping. So which one to remove now? So we discussed that it is surely better to remove the second one because it have higher endpoint. So in future there may be an interval which is non-overlapping with this but overlapping with the second one. So it is surely better to remove the second one. So let's just remove this and answer is 1 till now because we are removed second one. And let's come to this now. Even now the end of the last non-overlapping interval is this, and this is greater than the starting point of this one. So even now this is overlapping, and even now this have greater endpoint because we have sorted with respect to endpoints. So even now we can remove this. So the answer is 2. And same with this as well. Even the starting point is less than the endpoint of before, so these two are overlapping. And as this is sorted based on end times, it will have surely have greater end time than the this one, and it is better to remove second one. So now the answer is 3. And now let's come to this. So when we are at this point, the start point is this and the end point is this. So we can easily observe that we can pair with this one because they are non-overlapping, because it is like this. So there is no overlapping point with this both. So now the last interval which is in the set of non-overlapping is this one, and the end point is this. So from now we have to compare with respect to this because we got this and this, and now we should check with this one because it is already non-overlapping, and as we sorted with respect to endpoints, the newer one will have more endpoints, so we have to check with this one. So now let's come to this one, and as the endpoint now is this and the start point is this, it is less than the endpoint, so these two are overlapping, hence we must remove this. So the answer is 4. So in this way, if we try to sort with respect to endpoints, it is very easy to observe that as they are sorted by endpoints, at any point we can decide whether if it is overlapping, then yes, we have to remove the last one because we sorted with respect to end times. And if it is not non-overlapping, we can take this interval and we can update the endpoint of this one. So we can easily understand this by taking some examples. Now let's think of the other approach. Can we sort based on start times? So let's take another example. So these are sorted with respect to starting points. This and these all are sorted. The endpoints are not sorted. So now let's understand how this works. So let's assume whether this will work or not. So this is the first interval. So let's assume that this is the first interval of non-overlapping set because it's the first one. So let's assume this is the first one of non-overlapping. So this is the first one, and let's come to second one. So what is the problem here? Because the first one have very high endpoint and the second one will have small endpoint. But in the before one we sorted with respect to end time. So we are sure that removing second one is best for sure if they are overlapping. But now here the second one have less endpoint than the first one. So which is better to remove from these both? From this we can easily understand that removing the interval with higher endpoint is better. So in this both it will have more endpoint because it has a high endpoint. So it is better to remove the first one than second one. So we have some interval in the non-overlapping set, and its end time is less than the start time. So these two are overlapping, but it have less endpoint, right? So it have higher endpoint, and this endpoint is less than the last one in the non-overlapping set. So obviously it is better to keep this one in the non-overlapping set. So now we will remove the first one from there because it have the high endpoint, and it is surely better to remove that than the one with lesser endpoint. So we will remove the first one, and then how to update the endpoint? So we can simply update the end is equal to minimum of end of the before one and the end of the present one if they are if they are overlapping. So let's say this is the first one and this is the second one. These two are overlapping, right? And the endpoint of this before is this, and now we are removing this from the interval. So the new endpoint should be this because now we will compare with respect to this one because we are removing the first one. So how to make sure that this is the one that we are keeping in the non-overlapping set? So we can just simply update the end as the minimum value of this and this. So it will be surely this one. So by updating minimum, we are able to make sure that for the next of the intervals, we are taking this as the last non-overlapping interval. So now the set is this one because we removed this, and let's come to this. The endpoint, the start point is less than end, so we will remove this from the set because it have the higher endpoint. So even now if we update the minimum, this will be still be the minimum than this. So now the only set containing the second element, and coming to this, these both are overlapping with one element. So they gave that these are non-overlapping. So let's add this to the set. So the new endpoint will be this. So now the answer is 2 because we removed first and third one. And the start point of this one is less than this, so we will remove this as well. And we will remove this as well and remove this as well. And now finally coming to this endpoint is less than the start point, so we will keep this in the non-updated set, non-overlapping set. So the answer is 3. So the answer is 1, 2, 5. So the answer is 5. And the set overlapping are 3. So from this we can understand that we can sort based on both start and end times. But end times is very obvious because we are sure that the one we are at have higher endpoint than the before one, and we can remove this one if they are overlapping. But here it is not very obvious that the second one can have lower end time, and we can remove the first as well. So how to update in this? So we can simply use an end variable to specify the largest endpoint that is in the non-available non-overlapping set. And if we found a lower one which is overlapping with the previous one, we can update the endpoint saying that this is our new non-overlapping and we are removing previous from the overlapping set. So this is based on end times. So sort v dot begin and v dot end. This is a comparator, so we can sort with respect to end time. And answer is 0, size is 0. Size is the size of non-overlapping intervals, and end is v of 0, v of 1. Even size is not required here. So end is equal to the, we are assuming that the first one is in the non-overlapping, so we are updating the end and we are starting the loop and we are checking whether this is overlapping. If it is overlapping, we are going to increase the answer because we are removing the second one from our set because this is because we sorted with respect to end time, so we are removing the present one. If it is non-overlapping, we are updating the end because we are taking this in non-available set and the endpoint will be updated. So in this way we can return the answer. And if we sort with respect to start times, we are just sorting it, and even we are assuming that the first one is in the non-overlapping, so end is the first one and we are starting the iteration. And if it is overlapping, answer plus plus because we have to remove at least one. So if the endpoint of now is less than the endpoint of before, we will remove the top one, else we will remove the second one. So end is equal to, in either case we will remove one, so answer plus plus in any case. But finally, which one will be left will be based on the endpoints of both, and which one will be left which have less endpoint. So end is equal to min of end and vi. And if it is if it is overlapping, if it is non-overlapping, we are not going to remove an interval, so no answer plus this, and we are updating the endpoint and simply return the answer. So in this way, by sorting both, we can in any way we can return the answer. If you have any doubts, comment below. See you in the next video.